Hey, what did he say? Awesome, Lashawn. Thank you. So today we're going to be discussing troubleshooting Ethernet networks, determining whether the issue is at the switch, with the cable, the actual termination, or the drop itself. Whether you're dealing with support cases or validating installation or configuration, problem solving is critical for network technicians. Remember that this is a combination of mixture of technical knowledge, soft skills, intuition, and the discipline to apply a structured approach. We'll be learning the methodology for troubleshooting network issues. We'll learn how to explain the network troubleshooting methodology and most common cable connectivity issues. Network troubleshooting methodology. First, we want to identify the problem, establish a theory of probable cause, test the theory to determine the cause, establish a plan of action to resolve the problem, and identify the effects. We also want to implement the solution or escalate as necessary. Verify full system functionality, and if applicable, implement preventative measurements. Document findings, actions, and outcomes. Now, when we're identifying the problem, we're going to have to gather some information. And of course, we're going to have to duplicate the problem. In a lot of situations, you guys have dealt with issues as far as it comes to your ISP, Comcast, CenturyLink, and we all get frustrated with the standard, hey, can you unplug it, replug it back in? Can you duplicate the same issue that you're having? Can we see the issue that you're having? Can you show it to us? That's duplication of the problem. We're going to have to do that with users as well. As frustrated as they get, we're going to have to see that problem or that actual error code pop up if there is one. We're also going to have to provide the adequate questions that we need to for the users and the appropriate ones. Of course, we want to weed out any of the questions that we don't need to ask. We're going to identify the symptoms, determine if anything has changed, and approach multiple problems individually. You don't want to try to tackle a bunch of network issues in the entire building as one collective problem. Remember, just because one has a bad network drop doesn't mean that they're all going to have bad network drops. Establishing the theory of probable cause, we're going to question the obvious, standard things. Hey, is the network switch plugged in? Hey, is the jack plugged in? Is it nice, tight, and snug inside the telephone headset or into the computer? We're going to go top to bottom on the OSI model. And then, of course, we're going to divide and conquer to figure out what's going on and get everything fixed, especially when there's multiple problems. Testing the theory to determine the cause. Once you have a theory confirmed, you're going to take the next steps to resolve the problem. But if it's not confirmed, you're going to establish a new theory or escalate to, say, for instance, your network administrator. And that'll always be in a situation, for instance, if you're tier 1 support and you can handle as far as the cabling, the network, the drops, and the actual hardware itself, the workstation, you might have to contact your network administrator to be able to log into the switch because you might not have the permission to get into it such as myself with Rick. Sometimes I have to reach out to Rick and inform him like, hey, can you check the firewall? Can you check the switch? Can you log into it? Unfortunately, I don't have the credentials to log into that, but I've determined that the problem is not at the tier 1 level. It's not with the desktop. It's not with the cable. It's not with the jack. Okay. Identifying the problem, gathering information. We're going to identify the scope and prioritize. We're going to analyze logs and change documentation if needed, and we're going to verify with other technicians, especially when we're working with a MSP provider. Remember to keep your other technicians on the same page, and that's why we have support tickets, so you guys can actually provide documentations. That way, if your future predecessor or your future replacement ends up needing to refer to documentation, your support documentation is there. They can look into it and identify what the problem was the last time. Thanks, Jonathan. Okay, gathering information. At the outset, define the scope of the problem, that is the area affected. So if you have a network outage, for instance, this morning we had issues with the phone at the front desk. We want to determine the scope of the problem. Is it affecting just the phone? Is it affecting the computer too? Is it affecting the entire building? Is it affecting anybody else in close quarters in the offices? We want to figure out the area of the issue and the scope of what it's affecting. If it's just a single user, then it's not as urgent as any other outstanding call you have. Remember, prioritizing all your calls in your queue comes first. If you have support calls in your queue that have been there, for a day or two, address those first. If you have an issue that is affecting an entire floor, an entire office, make sure you delegate and make that top priority because that's affecting a lot more people than just one person. Okay. In addition, the fact that the problem affects a wider area is more likely the problem may be with one user's workstation. Knowing the scope of the problem can help identify its source and prioritize the issue in relation to other incidents. Like I said, if it's affecting an entire group, make sure you address that immediately as opposed to just addressing a power strip issue or, some battery issues with the mouse. Some information gathering techniques here that we're going to discuss are indirect sources of information. We're going to check the documentation. Remember, we went through installation and maintenance logs. If you guys are familiar with the A+ certification, remember we have our Windows log. And then as far as network goes, we did review over with Wireshark and packet sniffers. Check recent jobs or consult any other technicians that might have worked on that system. Remember, there'll be situations where a technician shows up and we're performing our routine updates, driver updates, firmware updates, and in some situations, some of those pesky Windows updates will update some drivers and cause the system to go down or corrupt the driver. So then referring to a previous technician that worked on the system, or as I said, support documentation in your support ticket system, you'll be able to narrow down if it was something that was done previously that caused the issue. Use vendor support sites. Remember, everything for like Cisco, Ubiquiti, and Juniper routers, they do have a knowledge base. So if you end up finding yourself stuck or in a rut, remember, documentation is always available. And most of those switches come with support for the first year. So you'll be able to contact them and they'll be able to provide you with anything that you need. Identifying the symptoms and duplicating the problem. If you cannot identify symptoms or duplicate the problem, there are additional techniques that you can use to diagnose the issue. Remember, questioning users and gathering information is a very important part of the job. You want to open with questions and invite someone to explain in their own words, like, what is the problem? What happens when you try to switch the computer on? What happens when you try to connect to this particular website and it has issues? What's going on that causes the system to stop connecting to the network? Sometimes people will try to transfer high amounts of data. Sometimes it's just something as far as, oh, well, I wiggle in my chair. Well, hey, look, there's a network cable right underneath your feet, and you tend to pull it when you wiggle a little bit, so it's causing a disconnection. Make sure to ask the common questions. Don't try to overwhelm your users with, actual terminology that'll overwhelm them, as far as saying, well, do you think it's a firewall issue? Do you think stick with layman questions? Close questions. Invite a yes or no to your response. Say things like, can you see any text on your screen? Do you see the network icon in the bottom right-hand corner in your taskbar? If you're on Wi-Fi, do you see that your Wi-Fi is connected, or do you see the globe that shows a disconnection from the network? And of course, you can ask other questions like that warrant that yes or no response, allowing you to have more close-ended questions and continue the conversation. Determine if anything has changed. There are two key questions in identifying the root of the cause of the problem. Did it ever work? Of course, hopefully your users will say yes, truthfully, it worked, it didn't work, but there are two different approaches required. If the system worked before 9 in the morning, you must ask, what happened before 9? What happened right before it didn't work? If the system never worked and you're not looking for something that stopped working, but for something that was never working in the first place, you might have a new client that contacts you and says, oh, my previous IT guy set everything up, and unfortunately, when he set it up and he left, our firewall doesn't work. It doesn't filter out certain websites or certain things. And of course, you're not asking when did it stop working. It's just a question of, hey, it was never set up and I have to set it up myself. The second question that you can ask as far as key questions is what has changed since last working? Did you have any updates? Did you install any software? Did you change any key components in the hardware itself? Did you have another technician work on this? These are questions that'll possibly lead you to the solution. Maybe the window cleaners were in the building. Maybe they had a cleaning crew in there that disconnected all the wires and connected everything back up. And perhaps it's not a network issue, but their speakers aren't working because their speakers were connected into the microphone jack. Okay, give me one moment, guys. Sorry, my dogs are excited. My significant other's getting home. So, as we were discussing, we want to check for documented changes in inventory, but if nothing reveals anything, we want to check the local area of the incident. And most of the time when you guys ask users general questions like this, most users will be truthful with you. They'll say, oh, well, last night I turned off my computer and I noticed it said it was doing Windows updates. Some other users won't come forward, and that's why we rely on event logs. Approach multiple problems individually. Now, before we get into the theory of probable cause, we're to learn about approaching the problems individually. We're not necessarily going to lump them all together. When you start investigating symptoms, you might discover symptoms of more than one problem. Perhaps a user has reported that a machine has lost internet connectivity, and you discover that it's not been receiving maintenance updates. The issues could be related, or it just might be incidental to the other. If these problems aren't related, treat each issue as a separate cause. If they seem related, check for outstanding support or maintenance tickets that might indicate causing problems. For instance, if you come into your job environment one day and one user doesn't have network access, then of course what you want to do is just address that user. But if you come in and you have everybody in just, say for instance, CNST, where we segregate everything by networks in each, let's say, section of the college, then you would want to determine and say, hey, this is a bigger problem. It's not isolated to one user. And of course, look into your support tickets. For all we know, there could be a firmware update on the switch, on the router, and we can even check with our vendors like Comcast Business and see if they perhaps have some maintenance being done in the area on the nodes. But that's something that you'll always go through and narrow down. Establishing a theory of probable cause. If you obtain accurate answers to your initial questions, you will have determined the severity of the problem, how many users are affected. And of course, here we have a model of probable cause. A rough idea of where to look, workstation or server, and whether to look for recent change over an oversight of configuration. Now this OSI model here, I'm going to try to pull it up in a bigger view here. Share it with you guys. As you can see here, you have your OSI model that we discussed in our first lesson. Those 7 layers from physical all the way to application. As you guys can recall, you see what they're responsible for. Top to bottom OSI model approach. Always remember this approach. Okay, going back to our slideshow. Start from either the bottom or the top and only move up or down when you have a disconnected layer as a source of the problem. Give me 1 second while this slideshow pops up. PowerPoint Live is taking a second. For example, when troubleshooting a client workstation, you might work as follows. Decide if the problem is hardware or software related to the system itself. Let me resume this. There you go. Decide whether the hardware subsystem is affected by the NIC card, the network interface card, or the cable itself. Decide whether the problem is the NIC adapter or the connectors, the cabling. Then test your theory by replacing the cabling with a known good one. As you can see there, you're going through your process of elimination as you work up the OSI model. First, you're checking your physical, your hardware, your network connector, the port on the motherboard, or a network card if it's a desktop and it's an additional add-on card, and then, of course, the cable. What would you usually check first, guys? If someone contacts you and says, hey, I'm not getting network to my computer, I'm not getting internet, and I'm not getting any signal whatsoever, what would be the first thing you check? Hmm. Yes, Tavares, you want to check the cables and the connection. You want to make sure the cables are good, but ensure that those connections, as far as the RJ45 jack, is clipped in nice and tight and snug. Then from there, you would check the network card. You could check the device manager as well and see if the network card's being seen in the device manager, if there's been a driver update that's causing the device to fail. And when you've drilled down like this, the problem should become obvious. Of course, if you've had made the wrong choice at any point, you must be prepared to go back and follow a different path or go through over the same steps again to determine what's wrong. Remember to divide and conquer. Rather than just starting at the top or the bottom, you can start with the layer most likely to be having an issue. For example, like I said, if you come in and everybody's having an issue at a network switch level, everybody in the building itself, check the switch. Check to see if the switch is on. In our situation, sometimes we have our server handle DHCP, and in that case, um, that sounds cool. And in that case, you would just have to go see if the server's on, because sometimes we have some internet issues, internet outages or network outages, and because the server's handling everything for DHCP, the server is off, there's going to be no network. So you just got to go hit the power button on the server. If you start network diagnostics at level 3 and cannot identify the problem, then you test level 4. Same situation. If you discovered a problem at layer 3, you would first test layer 2. If there's no problem at layer 2, then return to layer 3 and work up from there. Remember that you're working concurrently on a layer above or below of what you're troubleshooting. Test the theory to determine the cause. Isolate the problem to a single component or system. Remember, if it's a cable or a network card, go grab another cable. Grab your network tester. You can actually have a network tester that connect one cable from one end to the other and determine if the pin is bad, the pinage is bad, or it's just having a short. You can also test the network card. Take out the network card, insert another one. If the network is directly integrated into the motherboard, go grab a network card that can go PCIe or PCI. Insert that guy, get the cable installed, install the driver, and see if it works. Then you just have a faulty port. By questioning the obvious, you should be able to use one or more methodical diagnostic approaches. Hopefully, you've gathered enough data to come to an initial theory about the probable cause. Remember that you might be wrong. Sometimes it'll just be one thing. Sometimes it'll be a multitude of things. It's just the network adapter and the cable and the drop. Remember, it's not wrong to be wrong. If you cannot prove the cause of the problem, you'll either need to develop and test a new theory or decide to escalate the problem. Remember, escalation is referring the problem to a senior technician, a manager, or a third party. You may even need to escalate the problem for a lot of reasons. The problem may be outside of your knowledge or your ability to troubleshoot. The problem falls under a system warranty, like a Cisco warranty on a switch. It could be better dealt with the supplier or the vendor. We just switch out the switch and RMA it. The scope of the problem is extremely large, or the solution requires some major reconfiguration of the network. Remember what I was saying, like in my situation, I can troubleshoot anything as far as physical there at the college, but as far as logging into the switch, checking any port configuration, VLAN settings, or anything else, I don't have access to that switch. So I would escalate the problem to my superiors like Rick or Ken. Remember, a customer becomes difficult or abusive and demands help on an unsupported item. You would, of course, contact escalation. Like in my situation, it's always, hey, we have a Mac computer. It's not working with all data. Unfortunately, all data on their website itself states that it's not Mac compatible whatsoever. And I still get the questions, so I just reroute them to my superiors and say, hey man, I've informed these students and I've informed these individuals that this software is not compatible on Mac. They don't want to take my word for it. I've shown them the screenshots on the website. The only other thing I can do is escalate the ticket. And in most situations, it's just, yeah, I'll read their website. Some of the alternatives for the escalation can include senior staff, knowledgeable experts, subject matter experts, technical staff, developers, programmers, and administrators within the company. Remember, if you're used to being a network technician, but you're not so used to dealing with fiber optic or layer 3 switches that we were discussing yesterday, reach out to your seniority staff. They'll know something. If you don't know enough, in some situations, I've seen technicians call Comcast or UPN themselves and say, hey, man, we're a technician, we're new, we just started vending with you guys, and we need some walkthroughs with this. And they'll walk you through it and provide you support to be able to get things going up and running. Because what's a vendor going to do? Leave you dead in the water? Then you're not going to order components from them. When you escalate a problem, remember you need to establish the facts, gather as much documentation, and provide the scope of the problem and its likely cause to be able to communicate these to a person that you're referring the incident to. So remember, if you're going to someone, it's not like dealing with your insurance company. I'm going to transfer you. You get transferred. Then you have to explain the whole situation all over again. We try to avoid that with support tickets and documentation. And on top of that, when we contact one of our colleagues and pass on a support issue, we give them as much information as possible. And we also include the things and the steps that we've gone through to troubleshoot the problem, as well as any remedies and any changes in configuration settings, because the last thing that we want them to do is come into a situation where we change the configuration settings completely, didn't revert them back to their original settings, and they're essentially dealing with a minefield of problems and a whole completely new set of variables that they have no idea about. Establishing a plan of action. Assuming you're not planning to escalate the issue, the next step in troubleshooting is establishing a plan of action. An action plan sets out steps that you're going to take to solve the problem. There are typically three solutions to any problem: repair, replace, and ignore. Usually you don't want to ignore. You only ignore if it's something super menial. Repair, usually you determine the cost, break them down an estimate and a quote, how long it's going to take to do it, or reconfigure the switch or whatever you're dealing with. And of course, you provide them multiple options so they're able to say, hey, well, this is a cost-effective option like we were discussing with the Cat5 and fiber optic options. We can give them cost-effective options that won't give them the ability to stay cost-effective when we have to upgrade them at a later time. Or we can actually provide them an estimate with the latest tech that gives them that availability to upgrade without having to hit that much of an overhead. Replace. Often this is more expensive and more time consuming if the part's not available. There may also be opportunity to upgrade the device and software. Just as we were discussing with standard computer systems, a lot of people get sentimental and they rather pay hundreds of dollars for a motherboard that's no longer being manufactured. They have to get from eBay or from a third-party site like Memory for Less. The same situation when it comes to switches, servers, and any other devices. A lot of people would rather just deal with replacing that old, 100 megabit per second switch with the exact same switch, even though it's not manufactured. And then you're stuck looking into these old websites like eBay just to get the same hardware. And in their mind, as a client, they think, well, if we get the exact same hardware, we can implement the exact same settings with the configuration files that we backed up, hopefully that they've been backed up, and we would take less time to get us back up and running. Now, of course, in most situations with older parts like that, it kind of ends up being one of those scale balances where, yeah, it might be a little bit cheaper, but it's going to cost you more in time to do that because we have to look for the part. We have to wait so long, you're going to be down. Or we can just upgrade you, get you to a new unit, and you might be looking at the exact same cost, but of course, we're going to be taking the same amount of time, as opposed to just waiting idly by for a part to get shipped in. And of course, ignore. Not all problems are super critical. If the repair nor the cost is, if the repair isn't, worth it and it's not cost effective to repair it, it might just be best to find a workaround. And in most situations like this, I don't recommend doing that. I recommend repairing the issue or replacing it, because if you have a workaround where you have to disconnect and repower up a switch or do something all the time, that's really realistically not a solution. That's just patchwork, and unfortunately, bandages don't always resolve the problem. When considering solutions, make sure that you assess cost and time required. Another consideration is potential effects on the rest of the system, right? If you're replacing a switch and you have port forwards for a lot of other devices that go throughout the building, you're going to want to make sure that you get all that information. So when you bring in a new switch or upgrade the switch, you implement all those changes and it doesn't affect everybody in the building or on the second floor, third floor, or possibly across campus. You want to make sure that you address everything and note everything that's going to be affected by any changes you do. A typical example is applying a software patch, which might fix the given problem, but cause other programs not to work. This is an effective configuration management system comes into play, as it should help you understand how systems are interconnected and cause you to seek proper authorization for your plan. And that's found in most situations, especially with servers and networks. Network switches, remember we were discussing some software sets that use certain ports, 8080, 3030, DVRs, UDP, and TCP. You want to make sure that you have those switches set for any software that needs those ports open to be either provide updates or send information to other servers or via API. If the solution requires you to do a change, you are likely to have to follow a change management plan. If you do not have the authorization to implement a solution, you'll need to escalate the problem to a more senior personnel. In most situations, if I need to replace something on the network, I always have to involve Rick and or Ken so they can provide it in their documentation, notate it, and of course, they provide the hardware components that they recommend. If applying the solution is disruptive to wider network, you may also consider the most appropriate time to schedule the reconfiguration work and plan to notify how other network users work. So you might find yourself in a situation where you need to bring down the entire network, bring down the NAS drive, bring down the cloud, network system, whatever it is. You always want to be able to plan this out. So for instance, you need to replace a switch or upgrade it. Well, you want to do it on a day that hardly anybody's there. In my case, on campus, would be a Friday. Most people work 4 10-hour shift days. Um, so I can go out on a Friday. There's only 1 or 2 people there. I should be able to do anything that I need to while providing them information and saying, hey, I'm about to bring down the network, as opposed to bringing down the entire staff on campus. If the change does not fix the problem, this also allows you to reverse it too. Right. So say for instance, you're in on a Monday, you're updating the switch and nothing worked out. Well, great. It's a Monday. You're going to have to reverse it. You're going to actually have people be down more. You're going to have them be less productive because their systems aren't working. So you want to do that on a Friday, a Saturday, or Sunday when there's nobody there. That way it's easier to implement the changes, reverse, or go through the transition of having to boot up one switch, figure out what's going on with that, what configuration settings and ports, and then configuring it on the other switch. But of course, as you get used to this, you'll get used to the standard of going through every single setting in one switch when you're upgrading to another one and writing them all down or backing them up in a configuration file. Verify full system functionality and implement preventative measures. Remember, when you guys apply a solution, make sure that it works, not just for the user's workstation, but everyone else too. There are some situations that I found myself in when we have DHCP routing enabled for switches, and I get a phone call, we go out, the computer's not being able to access network, we fix it, we leave, and the next thing you know, we have an IP conflict issue because we didn't notice that because we didn't go to all the other work systems to make sure that they're that they're okay. Because you can fix one system and you can fix one thing, but if everything else relies on something certain on the switch or a specific IP address and that workstation took that IP address, there's going to be a problem in the network. In other words, identify results and effects of the solution. Ensure you were right. Make sure that the problem is resolved. Can you log in now? And is there any way that you can induce the problem again? Just because the problem is resolved doesn't mean that it won't happen again. Before you consider the problem closed, you should be satisfied in your own mind that you resolved it, and you should get the customer's acceptance that it should be fixed. You also want to have that sense of ease to say, hey, I know for a fact with absolute certainty that I won't be here again tomorrow with the same problem. If you do, make sure to double check your work. Now remember, once you get that acceptance from your customer, your client, restate what the problem was, tell them how you fixed it, and confirm with them that the incident log has been closed. And the reason you do that too is because a lot of the times, and I've had this happen personally from experience, we explain the problem to the client, we explain to them how we fixed it, and then all of a sudden, a month later, they call us and they're like, hey, everything's been running fine. And by the way, that thing that we've been having an issue with, we listened to how you fixed it last time, and we've just been fixing it the way you did. It helps the client. It helps you. It helps your team. Being informative, and not just your team, but your client, will make sure that it saves you a lot of time for a lot of problems that they can resolve themselves. To fully resolve a problem, you should eliminate any factors that cause a problem. For example, if the user plugs in their laptop into a wrong network jack, ensure those jacks are clearly labeled to help users in the future. If a faulty server induces hours of network downtime, consider implementing failover services to minimize the impact of the next incident. So this is a given. I've explained it to you guys before. When you're doing your network drops, make sure to label your drops in the office itself and your drops on the switch or patch panel. This makes sure that in the future, if you guys need to replace a patch, if you guys need to test a port, you know exactly where to go. You're not necessarily using a network analyzer tool to say, oh, well, this is connected to this port here. Oh, no. There we go. My PowerPoint's freezing up a little bit. Here we go. So remember we were discussing ticket system, support tickets, documentation. Remember to document your findings and your outcomes. Most companies have ticket systems that you should be able to get into. Very intuitive. You have a small example there. It shows you the contact, the POC, whoever's responsible to get a hold of when you get on site or whenever you have to call them. You have what the issue is related to or what other ticket this is related to. A small summary of the description of the problem. And then you also have an assigned to. Most companies will have this so they can assign their tickets to specific techs. Then CC users. For instance, if there was an issue on campus and they wanted to copy Bob or they wanted to copy Melinda, Miss Dr. Brown, we can CC them and they can keep up with the tickets and the updates. The due date, whenever it's due, the date and time the ticket was put in, the priority, and of course the category. You won't always have a category, but when you do have a category, hopefully those are broken down into network, maintenance, standard departments, so it can delegate the tickets accordingly to people's specific skill sets. And this is an example of Spiceworks IT support system. When you complete a problem, log everything that you did. And of course, other people are going to rely on it. Like I said, if you ever leave the company that you're working for and you have another technician come in, that support ticket documentation is not just for yourself, but also for your client and anybody in the future. That way, 10 years from now, if that company's still running, technician can come in and say, well, hey, Mr. Anderson fixed this years ago. He's noted in the support ticket that he changed out the switch because the switch went bad. That's been 10 years. Possibly the switch is bad again. Let's check that out. We want to make sure that we have all that information there for everybody.
In this video, we'd like to demonstrate the network troubleshooting methodology. In step one, we need to identify the problem, and one of the ways that we do that is gathering information. Now, we started gathering information when the end user complained that she could not browse to the company's intranet website to look at the employee handbook. Now, in doing this, one of the things that we want to do is gather a lot of information, but we also not only questioning our end users, we want to identify some of the symptoms. The symptom is, well, she opened her web browser, she tried to browse to the company intranet site, and it would not happen. So we determine if anything has changed. We identify the symptoms. The symptoms are she opened the browser, can't connect. The next thing is what we have to do is establish a theory of probable cause. And let's go ahead and do that. Before we jump into step 2, let's see if we can identify some of the symptoms by recreating the problem. Now, I'm going to go ahead and I'm going to open the web browser, and you'll see right away that we're not connected. First step of recreating the problem. Next thing I'm going to do is I'm going to try to browse to the corporate intranet site. I'm going to type in http:// and then we'll type in corp.515support.com and hit enter. Notice that we're not able to connect. So that is the first part in identifying the problem, is trying to recreate the problem. Now, the next thing that we have to do is we have to establish a theory of probable cause. And one of the theories of probable, or questioning the obvious, is part of that step in establishing the theory of probable cause. Now, one of the things that is obvious would be questioning the obvious is if the physical connections are maybe not working. This would be considered the bottom to top method, if you will, in the OSI model. Check the physical connections first. The next thing we have to do is verify that the network adapter is turned on and functional. What is one of the ways that we can do that? Well, we can actually go into the settings within our, in this case, Windows operating system, and we can pull up the properties of the network adapter, and then we can double-click on the network adapter, and we can see that the network adapter, well, it seems to have some information there, so it looks like it is turned on. But we can go a little bit farther than that. We can open up our network and sharing center, and we can look at the adapter itself. Now, the other way that you could do this too is just to right-click on your start icon and choose network connections. But when we open network and sharing center, and we choose change adapter settings, I can see that the Ethernet adapter currently is turned on, but we can check the status of it as well. All right, when we see that the network adapter, notice the media state is turned on. The next thing we can do is check the details. When we check the details, one of the things I'm going to notice right away is that we have an APIPA address, and that means that we are not communicating with the DHCP server. Now, my thought is now in the questioning the obvious is that if we have an APIPA address, we now need to find out why we're not getting a DHCP address. Now, we can actually try to force the renewal and the communication with the DHCP server. In order to do this, we can close these interfaces down, and we can choose the Start button and type CMD to launch the command prompt. Now, you can also in the command prompt type ipconfig like we've seen in the GUI, and you can look at the output here via ipconfig. Notice that we have our 169.254.anything.anything address, so we do know that we are not receiving an IP address from the DHCP server because it's falling back on APIPA. Now, we can try to start the DORA process over again by typing ipconfig /renew, and we can let this run. Now, the other thing that I'd like to do is I'd like to identify the scope of the problem. Is just this PC having the issue? Is it isolated to only this computer? Or are there other computers within my network that are having this issue? Well, let's find out. So while this is renewing, we're going to go ahead and we're going to switch over to PC2. And on PC2, what I'm going to do is the same process, all right? We're going to identify, is the network adapter on? And I can see down here in the lower bottom portion of the screen that, yes, we are currently, we have an adapter, and that adapter is turned on, but there isn't any internet access. So the next thing that we'll do is we'll right-click on that little icon and we'll choose Open Network and Sharing Center just like we did on PC1 and then change adapter settings, and I can see that the local area connection, the Ethernet adapter is enabled. If I check status, I can see that it's enabled. I choose details. Now I can see that this computer also has an APIPA address as well. So what I'm seeing here now in trying to establish a theory of probable cause is PC1 doesn't have an IP, well, it has an IP address, it has an APIPA address, doesn't have a DHCP lease. This computer doesn't have a DHCP lease. So now I'm starting to think that it might not just be PC1 that's having the issue. The scope might be a little broader, a little bit larger, and this might be an issue with the DHCP server. Let's jump back over to PC1 and let's verify whether it could connect or not. And it still doesn't look like it's connecting. So my thought right away here in testing my theory, if you will, my theory here is that the DHCP server isn't responding for whatever reason. Now I have to figure out, is the DHCP server on and is it functional? So let's go ahead and let's kind of move through the detective work here. I'm going to go over to MS1 and launch its console, because this is the server that you can see that is currently running the DHCP service, and we need to figure out what's going on with that service. To do that, we're going to choose Tools, and from the Tools tab, we're going to scroll down to DHCP. And then from DHCP, in the DHCP console, over here on the left-hand side, we're going to go ahead and we're going to expand out our domain. And one of the things that I notice right away is that we've got a couple of red arrows, red down arrows, in both our IPv4 and our IPv6 scope. So right here, what it's telling me is the DHCP server itself is turned on, but the service isn't offering IP addresses. So my theory, if you will, is that if we turn the DHCP server back on and we refresh the leases on both PC1 and PC2, hopefully we should see that we get an IP address, and it might happen before we even get a chance to get back over to those machines. So let's go ahead and do that, that's our action plan, if you will, to resolve the problem. Potential effects on this one could be that, well, if we turn back on the DHCP server, well, the potential effects are people will get their IP addresses, and that's what we want. So we're going to go ahead and implement our plan, because I'm pretty sure I've got this nailed down, so I don't have to escalate this to another tier, if you will. So we're going to go ahead, and what I'm going to do is I'm going to right-click on our server here, and I'm going to choose to restart DHCP. So let's go ahead and do that. Here on our server, selecting that, I'm going to right-click, I'm going to choose All Tasks, and what you'll notice here when I do that is that there is a restart option. So we're going to restart the DHCP server. You're going to see the service here is going to restart. That's what we want to see. We're going to allow it to restart. And what we're hoping here is when we choose these down arrows, now this isn't a dynamic page, so it could take a second. And what you want to do is you could just refresh this page. And notice that the moment I did a refresh, now what we see is we have green arrows. And if I expand this out and we look at our server scope, now we kind of see the IP addresses that are with, or the network that this scope is, range is. Let's go ahead and switch back over to PC1 and see if it's picked up an IP address. Now, it told me that there's an error that's occurred, unable to contact the DHCP server, so I'm kind of seeing the results of what my theory was. Let's go ahead and let's rerun the renew command. Let's see what happens here, and I'm going to minimize this because I'm a little impatient, and I'm going to right-click and open another command prompt because some of the other interfaces won't refresh, and that'll take a little bit. So if I do an IP config, now you'll notice that, well, guess what? We have an IP address of 10.1.0.101, so we are back with our network, and if I ping the DC, let's say ping our DHCP server, for example, I'm going to ping space ms1.corp.515support.com, and now you can see that we have an IP address and we're communicating with the rest of the network. The final process in this is to confirm that we can get to the corporate intranet website. So we'll go ahead and we'll refresh this page, and you can now see that we are on the corporate intranet site. So we worked through the problem, we implemented the solution, and we verified that we now have full system functionality. One of the last things that I might do, since I knew the scope was a little bit broader than just a single PC, what I can do here is I can actually disable this network adapter right from the interface, the GUI here, choose enable, and that'll actually do the same thing that ipconfig /renew did on PC1. And hopefully what we'll see here is that if we bring up a command prompt, we can do the same thing, potentially, well, not potentially, we will be able to communicate with that same server that's hosting the intranet website. So in this case, we will ping space ms1.corp.515support.com. And yes, we're receiving replies back. So in the last step here, now that we verified full system functionality, we can document our findings and our outcomes. And that is an example of how we